Hi and Assalamualaikum everyone. So today I would like to introduce our proposed invention product for International Invention, Innovation and Design Competition 2024 with the title WaferVision Integrated Semiconductor Health Analysis. We call them I.S.H.A. So first of all, I would like to introduce our project member. So this project is led by Muhammad Haris Iswan Sunain, student from Bachelor in Electronic Engineering, UTeM. So me, Nick Muhammad Zarifi from UTeM. Yang berbahagia Profesor IR PS Dr. Ghazali Omar and from UTeM, followed by Mahmud Dwi Sulistyo from Telkom University, Dr. Muhammad Nur Azlan Shah Zainuddin, Profesor Madya Dr. Wira Hidayat Muhammad Saad, Dr. Nur Hidayah Muhammad Yatim, and finally Profesor Madya Dr. Masrul Ahmad Ibrahim, also from UTeM. So first of all, I would like to introduce about this particular project. So based on the research has been conducted by DMCA, increment of demand of the silicon carbide wafer market up to 2029 was expected increase from 2022 price up until 2029 is very high demand. So based on that particular thing, so basically in failure wafer technology system, there will be one important department, so-called failure analysis department in semiconductor or wafer technology, whereby they involve about the investigation and resolving the issues that led to the malfunction of any kinds of wafer which produced by in one particular factory or company. So towards that, the failure analysis is basically done by observation manually by naked eye and observation in both naked eye with the machinery. And recently we have looking up in producing AI proposed methods to do the failure analysis instead of using the human and machine. So towards that, basically there are several problems to be catered towards this particular product. We need to be clear and specify the defect or anomalies of the responsible of each particular wafer technology that we have been using. So the root cause of the failure might be problem to the analysis process. So and then finally, the modern semiconductor devices are highly complex and consist of multiple layers, whereby it will be difficult to human eye to see several layers at the same time. So for this reason, basically we set several objectives for our project. So the first of all, we designed a new failure recognition application for the wafer. So mainly we will focus on cross-section failure analysis for a factory failure analysis department, so what we call it FA department. So then we try to prepare a stable, reliable and highly recognition accuracy in failure analysis for semiconductor sector. So and then last but not least is to ensure the application should be easy, friendly usage and could be accessed anywhere, anytime, easily, and required to have a report to evaluate the evaluation in real time. So this is the proposed product invention prototype. So basically we are developing a so-called an apps by using a mobile phone. So whereby this app, it could be done by directly capture the images from the cell phone itself, or we can import it from our storage on our image gallery. So obviously the apps is clean apps, friendly using, easy. We have several buttons to be conducted. So obviously cloud computing is being applied through the server in the cloud, whereby we push all the analysis that been done to the cloud and return to the classification result. And we also capable to present the percentage accuracy by displaying at the classification places. So this is the places that we need to upload the image over here, and we submit the image that we have downloaded or uploaded, and finally we will have the failure types kind of result over here. So this is the one that final touch of our apps. So whereby this is the uploaded file image. After we press the submit, then the E class is basically defined that this wafer is facing that particular E problems. Okay, so the way that we tell our authenticity and novelty, so in terms of intellectual properties and so on. So basically we try to propose our new synthetic data set for wafer failure analysis study. So nowadays, so there are limitation of that particular cross-section image datasets, whereby we only have the round shade of wafer from the top, so the blue, white shaded images, and this one green, kind of yellow and black shaded. So this is our proposed one. So we have the cross-section wafer datasets. Here the first systematic and intelligent cross-section wafer analysis application so far for the public testing usage. So speaking about the implementation level, so currently we are at the level number 4 based on the Malaysian Commercial Year 2.0 technology readiness level. So during the TRL 3, basically the classification task for accuracy has been conducted in lab using synthetic data samples. So and then we try to classify the application through finding the accuracy of tracing the failure by conducting into the NAPS Okay, so these are the back end of our product. So basically this particular image recognition selection methods has been developed by our lab, NMZH laboratory. So we call them I.S.H.A. So first thing first is giving the image, putting inside the neural network. So basically this is our own simple neural networks, convolution 1, 2 and 3. So finally dense, and we will classify it as a several category A until F. So where are we in wafer production line? So basically, where are we? We are not in diffusion, deposition, photo, lead photography, implant and etch, but we are here, metrology. So basically, we are trying to delivering a space to criticize the things that have been failure in the production line. So innovation, product impact, what we can and what we cannot do is basically achieve 90 plus 90% smart wafer analysis accuracy. So we could be implemented without any kind of usage of a huge machine and tools. Based on the standard neural network, it will be giving us a very reliable and accuracy. So we can use this application everywhere. The benefit of and the impact to the community and society is basically we are trying to open up and initiate the failure analysis using deep learning research, whereby we put some effort in and hoping that the many players will come in to join us. Here we provide a new synthetic data set images for the wafer analysis study, and also trying to use the real image, because the real image should begin with a collaboration with a real wafer technology players such as onsemi, Silterra, if I may say over here. So for the future, last but not least, is could be extended in a multi-type of wafer images. So and then it could be used as self-assessment among the assessor during the outstation time. So these are the demo of the mobile apps for our I.S.H.A. So first thing first is to find the photos from the library. We press images and we submit to the cloud computing. So finally that would be the E types of classification, FA result that we get. So speaking of the demo or desktop based app, so eventually there will be a rectangular kind of thing. So we press the button, similarly find the images in our desktop, download, submit, and we get the result for F category. So I think that's all for our proposed methods or proposed project. Thank you and have a nice day.